Alright, so in this video we're going to be talking about the points of discontinuity and how to find them. So what are they? Points of discontinuity are the vertical asymptote, which we look at denominator like in a previous video, and also looking at holes, what we can cancel out from the numerator and denominator. And those are the points of discontinuity, because if you try to plug them in, at that point, they won't work. And they're just bad. So to find out points of discontinuity, and also that, like, if you plug them in, you're going to get undefined. So that's why they're points of discontinuity, because they just don't work. And that's why whenever you're graphing, you always have to put like an open circle on them. So anyways, going on to this, you see we can't cancel them out right now. I mean, we got what is this? Two polynomials, one with a degree of 3 and one with a degree of 2. So we got to simplify this. So first I'm looking over here. We got 4 terms in our polynomial, so we could group this. We could factor by grouping. So like over here, let's see, 3x cubed plus x squared, let's group that. And then over here, the negative 12x and the negative 4. Let's group those. So over here, what's common in both of those? X squared. So now, let's bring that x squared out, and then it's just 3x plus 1. Over here, since we always want the front leading thing to be a positive inside the parentheses, then we just factor out a negative 4. And then we get 3x plus 1. So now you see, our factors are 3x plus 1 and x squared minus 4. So now, let's go on to our simplified part of the top. So basically, it's x squared minus 4 times 3x plus 1. However, we have to simplify the bottom. And to simplify the bottom, you have to factor it. So let's get to factoring this. And here we use the a times, what times a and c is negative 6. And then b is negative 5. So what times what can equal negative 6 and add to negative 5? Well, if you think about it, you could just do, let's see, you could do negative 6 and 1, right? Negative 6 and 1 multiplies the negative 6 and adds to negative 5. So over here, now let's just bring this down here. Over here, now you got your 6x squared minus 6x from that negative 6. And then you got the x minus 1. So over here, it's already factored out. You got your first factor. Second factor, you got that 6x that comes out of the 6x squared minus 6x. And remember, there's a 1 here. So then when we're factoring out, we get 6x plus 1 and then x minus 1s as our factors for the denominator. So over here, oops, I kind of wrote it out. From here, it goes to the factors we got here, which are x squared minus 4 and 3x plus 1 over 6x plus 1 over x minus 1. And then we can simplify this into x plus 2 and x minus 2, so that's what I did. So now, when I'm looking at this, my simplified equation from that, a lot easier, right? So now, I mean, are there any holes? Can anything from the numerator and denominator cancel out? No. So for this equation, we know for points of discontinuity, let me just write that for short, there are no holes. And now we just look at our vertical asymptotes. Because none of them cancel out. I mean, there's no x plus 2, x minus 2 on the bottom. There's no 3x plus 1 on the bottom, you know? None of them, they're the same. So, anyways, now we look at the vertical asymptotes, which is pretty easy. We just look at the bottom. And now we know our vertical asymptote, one of them is x minus 1. that means our vertical asymptote is x equals 1. So there's 1. And then our second one is 6x plus 1. So 6x plus 1, set that equal to 0. And then we get 6 plus 6x equals negative 1. And then later, x equals negative 1/6. So there's our second. And yep, those are the points of discontinuity. We're just finding the holes and the vertical asymptotes of an equation. And those are basically the points where if you plug in that x, you will get an answer, but like it's undefined. Because like if you plug in negative 1/6 here, then you'll get like all of a sudden this will equal negative 1 plus 1 is 0. And if we divide that whole thing by 0, 0 times this is going to be 0. And it's going to make the whole like equation like, oh my god, I'm losing my words. But anyways, it would make the whole equation undefined at that point. So anything that when you plug into the denominator and it makes it equal to 0, since it has to multiply the other thing by 0, then you're going to get it undefined. So the same thing with 1. I mean, if you put 1 minus 1 is equal to 0, and 0 times anything is 0, and then divide this by 0, and it's undefined. Same thing, negative 1/6, you get negative 1, then negative 1 plus 1 is just 0. 0 times this, 0, and it's undefined. So that's why these are our vertical asymptotes, and there's no holes because you can't cancel them out. So our points of discontinuity are no holes and vertical asymptotes of x equals 1 and x equals negative 1/6. Let's go into another example. So here's another example. We got x squared minus 1 over x minus 1. And now, let's first see, can we simplify anything? Well, the bottom's good. However, the top, x squared minus 1, we could definitely factor that out and make it x plus 1 times x minus 1 over x minus 1. Just write it off to the side. However, you can cancel them out like I just did here, because x minus 1 and x minus 1, they're both on the numerator and denominator. They can just cancel out. So then you're left with y equals x plus 1, and your whole is x minus 1. And now, x minus 1, you set that equal to 0, and your x value for your whole is 1. You get a whole at 1. Now, so since there's a whole at 1, you could also find the intercept of the whole if you want. I mean, you know, if you plug in 1 to this solution, then you will get basically an undefined answer. So that's why a whole is a point of discontinuity. But the y, I mean, if you were to graph this, to find the y, it's really easy for a whole, because a whole is just 1 point, a point of discontinuity. And so basically you just plug 1 into x here, and then it's just 2. I mean, your whole would be at 1, 2, and the x value would be x equals 1. And as for vertical asymptotes, you always look at the simplified version after you cancel out the holes. So now you're left with x plus 1, and that's basically over 1. So since there's nothing on the denominator except a 1, for vertical asymptotes, there's none. So those are our points of discontinuity here. Basically, I mean, so the points of discontinuity here, what we did is we factored out the top because we need to. We make sure that like the problem is as simplified as possible, so that so like with this x squared minus 1, we factored it out, and now we have all terms that we can actually work with. And then we look for, is there any holes we could cancel out? And if there are, then good, cancel them out, and then use your new equation to find any vertical asymptotes in the denominator. And if not, just like look for vertical asymptotes in the denominator. And yeah, and then we found out that there's a hole at x minus 1, so that's x equals 1. To find an exact hole, like a point, then you could just plug it into the y to get that exact point on the graph, so that you know, let's say the hole is at 1, 1, right here it's like 1, 2, right? Then 1, 2, there would be a hole here wherever the graph is going or whatever. And yeah, so in general, just a summary, To find the points of discontinuity, you first simplify out the equation as much as you can until you get terms like these, if you can, of course. And after that, you look at any holes you can cancel out. If you can, cancel them out and then put the new equation with what's left. And then you solve for the vertical asymptotes in the denominator by setting them equal to 0 if they have x in them. And then you got your vertical asymptotes, and then you got your holes. Your holes, whatever you cancel out, you set that equal to 0, and then whatever x equals is your hole. And if you want, you can plug that back into the new simplified equation, and you could find a y value for your hole. So you get your hole is at x equals 1. So on the graph, whenever x is 1, if you plug in 1 over here to the simplified equation, you get 1, 2. So at 1, 2, you're going to have your hole, which means that whenever you plug in 1, it just won't work. You'll get undefined. So there's your hole, x equals 1, and blah, blah, blah. If you just plug it into the new equation, you get 1, 2, and you got no vertical asymptote. Since that's the simplified equation, there's nothing on the bottom. And yeah, points of discontinuity, I hope you enjoy.